In this lecture, I'm going to talk about one of the other classifier called NaiveBayes. NaiveBayes is the most straightforward and fast classification algorithm. NaiveBayes classifier is successfully used in various applications such as spam filtering, text classification, and recommender system. It uses Bayes' theorem of probability for prediction of unknown class. It is one of the simplest supervised learning algorithms. NaiveBayes classifier is the fast, accurate, and reliable algorithm. Also, NaiveBayes classifiers have high accuracy and speed on large databases. What is NaiveBayes classifier? The Bayes theorem is a very popular mathematical formula that is used to determine the conditional probability of an event based on prior knowledge of conditions that might be related to the event. NaiveBayes classifier assumes that the effect of a particular feature in a class is independent of other features. The theorem, Bayes theorem, is based on pH, probability of D equal to PDH, pH divided by PD. In this case, pH, the probability of hypothesis, H being true, regardless of data. This is known as the prior probability of H. Probability of H. P capital D, the probability of data regardless of hypothesis. This is known as the prior probability. PhD, the probability of hypothesis H given the data D. This is known as posterior probability. PDH, the probability of data D given that hypothesis H was true. This is known as a posterior probability. Let's have a look. How does NaiveBayes work? Let's understand it using an example. Below, I have a training data set of weather, and corresponding target value or variable play. For example, play is suggesting possibility of playing. Now, we need to classify whether players will play or not play based on weather condition. Let's follow the below step to perform it. What is step 1? Step 1 is to convert the data into a frequency table. Have you seen the frequency table? Here, for example, you have the weather, sunny, overcast, rainy, sunny, overcast, and the play is no, yes, 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 no. The frequency you can categorize. For example, if weather, no, yes. And if overcast, for example, we can not see anything here, but suppose it's 0, and also it's categorized if the weather is yes, overcast should be categorized as 4. And in the rainy part, if the weather is no, it's the frequency table is 3 that we have here. You see here, rainy, yes, and we talk about rainy, no. How many we have? 1, 2, 3. Sorry, 1, 2, 3. And we have 3 frequency table for rainy, which is the weather, and player cannot play. And for example, for sunny, if the weather is sunny and the player can play, let's see how many times we have no in sunny case. 1 here, another one is here, 2. The frequency is 2. And also step 2, after you make the frequency table based on the input and output, let's suppose you have to do the likelihood. So the likelihood is another table. For example, after you created all these for rainy, sunny, and overcast, rainy, sunny, overcast, this is the grand total. Let's suppose it is the sum of this frequency table, these 2, 3, okay? Sunny, rainy, overcast. Total frequency in terms of no, it is 5. Total frequency based on this variable is 9. Now we have 5 and 9, okay? And likelihood table for the part of no equal to 5 divided by 14. 14 is total condition, and 9 divided by 14. This is the likelihood table for the situation with no is 0.36, and for the situation yes, it is 0.64. And also for the overcast, we have another situation here. For overcast, when you want to calculate the likelihood, you have 0 and 4. 0 plus 4, for example, 4 divided by 14 situation that we have. The likelihood table for overcast is here, and for rainy, 5 divided by 14, this one, and sunny, 5 divided by 14 is this one. So now we have to go to step 3. What is step 3? Use NaiveBayes equation to calculate the posterior probability for each class. I told you what is the posterior. Posterior is this one. P D H, the probability of data D given that hypothesis H was true. First you have to calculate this, then you have PH and PD. At the end you can reach to PhD. So the class with the highest posterior probability is the outcome of prediction. So for step 3, I will look to problem. Players will play if weather is sunny. Is this statement is correct? For example, if you say P yes, probability yes, sunny equal to P sunny yes multiply P yes divided by P sunny. This is based on this equation based theorem that I told you. So we have to calculate P sunny yes. How many times? 3, and based on the yes and divided by 9. This is total 0.32. And also P sunny 5 times and divided by 14 equal to 0.36. sunny. You see, 5 divided by 14, 0.36. And how about PS? 9 divided by 14. You see, this one is sunny, let's suppose. And if the likelihood table, you refer to likelihood table, you can see that 9 divided by 14 is 0.64. Now we have PS sunny. How can we calculate PS sunny? I told you P sunny yes. P sunny yes you already calculate. PS you already calculate divided by P sunny. Then you have 0.60 which has higher probability. That is why you already catch the highest probability. Now we are going to talk about NaiveBayes classifier in Python and how we implement NaiveBayes in Python. You already learned how a NaiveBayes classifier works. Let's try to build a classification model based on it using scikit-learn. Scikit-learn or scikit-learn is an open source machine learning library written in Python. We already discussed. For the purpose of this article, we will be using social network ads dataset. We have a dataset I already uploaded here. In this problem, we will try to predict whether a user have purchased a product by clicking on the advertisement shown to him or her on social media based on age and estimated salary. Let's get started. Like the previous section, we have to import library. First, we import the necessary libraries such as NumPy and Pandas to work with data. At the beginning, you have to do this too. We work with matplotlib for plot figure and use listed color map. You see here, this is the new one. Listed color map to generate from a list of color. From scikit-learn, we import Gaussian based network NaiveBayes to classify based on NaiveBayes Gaussian. We use a standard scalar to standardize features by removing the mean and scaling to unit variance. Also, we use train test split to split dataset into random train and test subset. Finally, we use confusion matrix and accuracy score to evaluate the performance of model from scikit-learn. Next step is to import the dataset. Let's try to run it. Next step, we import the dataset. The dataset downloaded and saved in data folder. The last column is target or label for data and other are feature. Let's read this data and you see dataset already read from the social network ads and 5 row already mentioned here, the head. Dataset.head can show the 5 rows from the dataset. Age, estimated salary, and purchase. This is include 3 columns. For example, here first index is 0, represent the person that his age is 19 and estimated salary is 19,000. Okay, 19,000 per year. That the target is 0. That means this person did not purchase anything. So let's have a look to another section. We store feature in X and label in Y. After you read the data, you have to split. First, you have to store the X and Y. If you want to store some part of data as an input to the X value, you have to put X equal to dataset.I locate or location. This one we already discussed in Python introduction, that value, and Y, the last one, will be located to Y. Then here I print the length of X. See, the length of X now is 400. So the next step is to split the dataset into training and test. X train, X test. Y train, Y test. It should be like train test split X, Y, and we already got the test size 20%. The remaining is for training size 18%. And when you print the length of X test and X train, you will see this one from 400, 80% is for training, and the rest of number 20%, which is equal to 80 sample, is for testing. Let's print X train. This is the X train. Exactly they mentioned to you what is it. And here is Y train, which is located for last column, which is for Y. And X test, they want 20%. They already show you. And Y test, they can show you with this value. Again, I can repeat. We select 80% of data for training and 20% for testing. We have 320 sample for train phase and 80 sample for test phase. You can see the label and feature from different training and testing data. Now it's time to go for scaling, feature scaling. A standardization of dataset is common requirement for many machine learning estimators. You have to do a standardization. They might behave badly if the individual features do not more or less look like a standard normal distributed data. For example, Gaussian with zero mean and unit variance. Let's have a look how we standardize this X and Y with the SC equal to a standard scalar, and we already standard. Let's print it. This is the standards, and also we have standards for X test, X train, and X test. If you look at the previous one, your X test, and let's have a look to X test is look like this. Okay, you have to normalize or standardize by this and X test. So these two values are not very close or similar together. That is why we use this standard scalar. Then most value came to the very similar range. The next step is to train the NaiveBayes model. In order to train it, we built a naive model from trained data by using this command. This command is training the NaiveBayes classifier equal to Gaussian NB and classifier. Now it's time to fit to train and X train and Y train. Let's have a look. Then the Gaussian NaiveBayes already done. It's time to predict. After building, we use the data, for example, a person of 30 years of age and 87,000 annual weight to predict the label and target for it. Here we have to define. Again, I can repeat it. After building the model, we have to do predicting. Predicting of what? A person of 30 years of age, for example here, and 87,000 annual wage to predict the label and target for it. After we see this 0. The model predicts 0. That represent this person will not purchase company's product. Predicting the test result. This is one sample, a small sample prediction. Okay, we use transform and now it's time to predict for the test data by using classifier.predict test data. And after we concat the data by predict and by test, we can run, and you see that this is based on the test. This is the y test, this is the y predict. In other words, we call y and y hat. That is why they seems to predict very accurate, good accurate at least. Now how to see the performance is good? You have to get some performance metric to see what performance is good. We use confusion matrix and accuracy. I told you this is the confusion matrix between y test and y predict. And accuracy, y test and y predict. Let's see, after we use the CM confusion matrix, I want to print it, and later we want to get the accuracy score. Let's see. This is confusion matrix, true positive, true negative, false positive, false negative, and this is 91% accuracy score that we achieve. Now it's time to visualize the training test set result. This is the amazing part of machine learning that you can do. This step is not necessary. It has been put up just to give an idea of how data points have been classified by the model. Let's run xset yset, and we call inverse transform, and we do some formula, then we use the mesh grids and contour, and at the end we put 1 4 ij in emulates np.unique y test. Then we already predicted NaiveBayes algorithm. Let's see, after they run, they will show us some models and some visualization. So let's have a look and wait for this one. In this case, you have to wait in order to get the accurate result. I will explain the result in next slide. After we run and visualize the training set result, we can find this nice figure, such as red and green color. The red color shows the class 0, and the green color shows the class 1. Means that they already categorized based on this nice figure. Also, this line is between two class and work as decision boundary. You remember the decision boundary in logistic regression. This is the decision boundary. So let's have a look to visualizing the test set result. After we run the training set, you see that the result is something like this. X and Y is age and estimated salary, and in terms of NaiveBayes training, you achieve to this graph or figure. Now it's time to wait for getting the result from the test section. I will explain to you in the next slide. Before I explain the visualizing the test result, have a look to visualizing the training result. You see that some points or sample mistakenly put inside another class. For example, class 0 put in or categorize or classify in class 1. So in terms of testing, the result is much better. Most classes keep in the right position. For example, this is the result from the age and estimated salary by using NaiveBayes in the test section. Here also 0 or red color shows the class 0 and green color shows the class 1. The last step is to describe about zero probability. Suppose there is no tuples for a risky loan in the dataset. In this scenario, the posterior probability will be 0, and the model is unable to make a prediction. This problem is known as zero probability because the occurrence of the particular class is 0. The solution for such an issue is the Laplacian correction or Laplace transformation. Laplacian correction is one of the smoothing techniques. Here you can assume that the data set is large enough that adding one row of each class will not make a difference in the estimated probability. Therefore, this will overcome the issue of probability value to 0. We will discuss and give you more example of zero probability problem in next lecture.